Exploration has three fundamental questions. Are we alone in the universe? Are there other habitable planets? And is there life? When are we going to find it? The evidence is mounting. I think in the next decade, we might find past life or current life throughout the solar system. You're watching these fireworks, these cosmic interstellar fireworks. This is from our magnificent Hubble Space Telescope. To search for these questions, are we alone? Are there other habitable planets? And what about life? You've just seen stellar formation of 3,000 stars. So what guides my work and the research is thinking about all of our exploration and what it means for us down here on Earth. You're seeing an image of Earth from our Discover mission. It's like a space weather buoy. It's at the Lagrangian point, Earth and the sun. And then 1.5 million miles out there, there's a space weather buoy saying, hey, Earth, guess what's coming? All this space radiation, space weather. How about Mars? That's my passion. We will become interplanetary. We'll send people to the moon next and onward to Mars. Mars, at half the size of Earth. It seems very dry and cold, but guess what? We just discovered organics. Guess what? We have seasonal water on Mars. We know there's ice on the North and South Pole. So those are the building blocks of life. I think 3.5 billion years ago, it's likely that Mars had life. Earth and Mars, sister planets. Life worked out pretty well for us here on Earth. What went so terribly wrong on Mars? It lost its global magnetic field, and its atmosphere today is only 1% carbon dioxide. So the story continues. Tell you a little bit about the research, first for Mars, and then bringing that home to Earth. We've been to the moon. These are my Apollo bloopers.
Jack Schmidt having a few problems.
So as an aerospace engineer, rocket scientist, I'm thinking, how do we enable astronaut performance on the moon, 1/6 gravity? Essentially, the design is taking a spacecraft and shrinking it down to the human. It's an amazing engineering challenge. I call it the world's smallest spacecraft. But you can see it's pretty massive. It's not very mobile. It definitely wasn't enhancing the science that we could do on the lunar surface. In the middle, that's our current system. At 140 kilos, our design goal is to throw technology, innovation, what can we do to reverse that paradigm? Rather than literally the man in the can, how can we make a suit that is based on your performance, your design, a custom suit? It's literally called a second skin. Let me show you where I think the future is going, to enable exploration. Why? Because we're not going to stand around on the moon, and when we get to Mars, we're going there to search for life, past evidence, or current life as it exists today. So this is our design. We call it the biosuit. It's an order of magnitude less in mass, and it's very flexible. You get your own suit, you get a custom suit, everyone gets one, so we won't have that problem with not being enough suits, especially for women. How do we design it? Well, we map you in motion. So the design philosophy is to literally look at your motion, your movement. These are stress-strain fields on the elbow. And if I map you, put little infinitesimal circles all over, I want to empower you, because Mars is 3 times, the highest mountain on Mars is called Olympus Mons, and it's 3 times Mount Everest. The largest canyon is Valles Marineris, and that would stretch across the entire United States. So now who wants to go on my 4-year Mars mission? Come on. All my students still want to go to Mars, but it's a tough challenge. Why do we do it? Because it is the hard thing to do, because it's challenging. That's why we explore fundamentally, push ourselves, as an engineer, push ourselves to the limits. Now let's bring it down to Earth. All of our exploring, I submit, is for one reason, and that's to learn about life here on Earth and to be in balance with the Earth. So I think Bucky Fuller said it the best. To make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without any ecological offense or any disadvantage of anyone or to any living being. What you're seeing then is from NASA and our European Space Agency, the eyes on Earth, all of our satellite data hosted on AWS, much of it, and the supercomputer simulations. So we can look at the ocean's changing, the currents changing. We can see literally through the clouds, agricultural, soil moisture and mapping, the temperature in the seas, the currents, all of this holistic look at Earth and all of our systems. Our systems are oceans, land, air, and then from near space, eyes on Earth. So if we look at Earth, I'd like to show you the vital signs, because to me, Earth is a living, breathing, enormous being that we really need. We, humanity, we need Earth. Earth doesn't need us. Here's global temperature taken since 1880. Blue and white are 1 to 2 degrees Celsius below a running average mean of 30 years. Yellow and orange are 1 to 2 degrees Celsius above an average. You can take a look at the decades. If you want audience participation, raise your hands. We're going into the 50s here. Going to go into the 60s. All right, 70s. Thank you for participating. Here comes the students, 2000 to 2010. It's hot. 2016 was the hottest year ever recorded. It was an El Nino year. 2017 was second. Matter of fact, I can show you data for each month now. We're setting records. We're surpassing records. We all know the studies. 2 degrees does change our world. We're at 1 degree now. So, the vital signs. I'd like to show you global carbon. We don't want to be above 410 parts per million. Yellow and orange are going to be above that threshold, into the 400s. Blue is into the 300 parts per million. This is just 1 year in the global carbon dioxide cycle. It's from 2014 to 2015. I want to show it to you in 3 dimensions. You're literally looking down through the atmosphere. 5, 10, 15, 20 kilometers up. This is human cause. This is us. Sure, and some natural disasters, the forest fires. But these are our emissions. But we can do something about it. I remain eternally optimistic through spontaneous cooperation for all of us working on this together. The Earth's vital signs. The Earth is breathing, the Earth is speaking, but are we listening? My last Earth vital sign is going to be the glaciers. I had the distinct privilege, as you heard, to serve at NASA, get to South Pole. I'm a scientist, I'm an engineer, I can't get enough data. How are our glaciers doing? Greenland and Antarctica, they hold 99% of the world's fresh water trapped in our ice sheets. They're melting quickly. Take a look at this simulation. Take a look at the latest campaign, flying campaign, looking at the atmosphere, ground penetrating radar. We look at the land, we look at the oceans. You can see the velocity vectors of the ice melting, the Greenland ice sheet. There's the numbers, just under 300 gigatons in 1 year. Antarctica, the same year, lost 125. So we're at 400 gigatons of ice lost in 1 year. Well, what does that mean? Well, that's 3 times the size of Texas. This is causing the ocean to rise. If the Greenland ice sheet goes, that's 6 meters of sea level rise. Since 1990, we're here, we're 2025, but it's on an exponential curve. So, Earth's vital signs. We need to listen. Earth is speaking to us. What can we do about it? We have a lot to do about it. So, at Earth DNA, that's our nonprofit, taking all of the NASA data, the satellite data, the atmospheric data. There's so much data on opendata.gov. What can we do with it? It's overwhelming even to the scientists. We can curate it. We're using a lot of artificial intelligence, most recently GANs and generated adversarial networks, to curate that data so it makes sense. Because you know what? I can show you global data, the vital signs of Earth, but what you care about is maybe your state, regionally, local. And guess what? You really care about personally, you and your family. So we want to put it literally in the palm of your hand. Those terabytes, gigabytes daily of data. So you curate your own dashboard. What does it mean to you? Well, as an explorer myself, I really care about the oceans. I think we can really accelerate change, positive change, if we look at the oceans for all of climate. Let's look at the oceans. These are our biggest challenges. The ocean warming, sea level rise, I mentioned, the acidification of our oceans, overfishing, and pollutions, and the micro-pollutions. So then my story, what does that mean to me? Well, I'm a sailor. We circumnavigated sailed our boat around the world and survived, so I'm here talking to you. But what did we find? All those stories, those island nations. People understand sea level rise. They understand living in balance with the Earth. So if you look at the oceans, then we can put it in the palm of your hand. What can you do? We can change. As a scuba diver, if you're scuba divers and love the underwater world to explore just like I do, you know, in 1 year, last year, we just lost 30% of the Great Barrier Reef in Australia. That's the effect of temperature. That's the effect of these vital signs of Earth. So they're right in front of us, but I can give you all the data in the world, and I still say that's the easy part, curating the data, giving you this platform, letting you make sure that you have your own dashboard, so you type in your zip code, because it matters to you and your family. What else can you do about it? Well, I can change my carbon footprint. Surely I can. What do we eat? What do we all eat today? What mass transit do you take? So I don't have the solutions for you, but I know what my solutions are. So now I wake up each and every day and say, what's the most important thing I can be working on? And my answer is this: having the discussion, sharing the news, the vital signs of the Earth, and empowering everyone to take an action. It can be a small action every day so that we get this done within the next decade. I might have 2 decades to become interplanetary, get my students to Mars. But I really think it's so critically important that we have this decade to really accelerate change and live in balance with Spaceship Earth. We have an advantage from space, looking down. Earthrise, you're going to hear next, and it's the overview effect. All astronauts are transformed when they look back down on our beautiful blue planet. So we want to make sure all the girls and boys out there can have the same experience. Thank you very much for your attention.